Steve here. We got a nice interest rate problem, and everybody likes to watch money grow. So watch this, and hopefully we'll show you how to grow some money here. So the problem says, how many years will it take for an initial investment, $60,000, to grow to $90,000, assuming a interest rate of 12%? Here's the key word: compounded continuously. So that's the key we're going to need for this problem. You might have other interest rate problems, like it's going to be compounded monthly or quarterly or whatever. If you have that type of problem, message me and we'll help you with that type of problem. So for the specific case of compounding continuously, there's a formula that most of your algebra books should give you, and most of the time it's in this form. So A equals P times E raised to the RT. So what is A? A is the value in your account now, basically where it's grown to. And so in this problem, what is that? So it's going to grow to 90,000. So A in this problem is going to be 90,000. P is the initial amount that you invested, often referred to as the principal in the account. Well, so your initial investment here was 60,000. So in this case, P is going to be 60,000. Now E here, this is that exponential function, right? You've learned about exponentials here with exponential curves going like this. So you might have on a calculator like the E term, E to the X. So E to the 1, if you were to type that in your calculator, it should be about 2.7 in more decimals. So that's the function you're going to need for this. And R, what's R? Well, that's the interest rate. So here they give you the rate as a percentage, but the key here is you need to have it as a decimal. So what is 12% expressed as a decimal? So you take 12% divided by 100%, 12 over 100, what would that be? That would be 0.12. So that's another key. There's a lot of little steps here. You got to get everything just correct. And so the interest rate as a decimal is 0.12, and T in this formula is the amount of time in years. Okay, and so that is everything. So if I look at this expression, I know my A, I know my P, E is given, I know my R. The only unknown here is T. So how many years will it take? Okay, so the first step, what I'm going to do is take this formula and I'm going to rewrite it. So I'm going to divide both sides by P. So A over P will be on the left, and if I divide by P on the right, notice the P cancels, and I'm just left with E raised to the RT term. Now here's the tricky part. So if you think about sort of undoing something, right? If I add two things, then I can like subtract it to undo it. So to kind of undo an exponential, you need to use what's called a log function, and specifically you need to use the natural log. So here's what I'm going to do. I'm going to take the natural log of both sides. So the natural log of the A over P that we found previously, I'm going to take the natural log of the right side. Remember, whatever I do to the left, I have to do to the right. I need balance. So when I do the natural log of E, it basically undoes it. And all I'm left with now is the RT term. Okay, very important step right here, because what are we trying to do? We're trying to isolate the T variable and just have an expression just in terms of T. That's our goal here. Awesome. So now all I needed to do for my last step is just divide both sides by R. So RT divided by R just leaves me with T, my isolated variable, and then I can just bring my R right here. So now all I need to do to solve for T is go back, look at what I've assigned my variables over here. I have my A, and I have my P, so I can divide these two, 90,000 over 6,000, and again, we just don't need the zeros, it's just 9 over 6. So the natural log of 9 over 6, what's that answer? Divided by R. As a decimal, you can't write by 12. It has to be 0.12. It has to be a decimal. So do that, and you should get your answer for how many years it's going to take. Now, one quick last comment is it might give you, it's probably going to give you a decimal, right? It might give you, I'm just picking a number here, 5.67, right? So what does that mean? That's going to be 5 full years and then 0.67, right? That's 0.67 of a year, which is about 2/3 of a year, right? 12 months in a year, 2/3, you could do the math, okay? So just understand that interpretation at the end. Okay, wish you well and hope to see you next time.